Hello, this is not your chem tutor, and in this video, I will teach you how to solve for mass percent. So mass percent is one of the many expressions of solution concentration. And in this video, I have also included a couple of practice questions for you to be familiar with the types of problems involving mass percent. So the questions get harder as we go along the way. Mass percent is also known as weight percent, percent by mass, percent by weight, percent mass per mass, or percent weight per weight. It depends on what reference you are using. But all of them just mean the same thing. In chemistry, when we say mass percent, we are usually referring to the mass percent of solute in a solution. So the formula for the mass percent of solute is mass of solute divided by mass of solution times 100. Students usually ask, what unit of mass should we use in computing for mass percent? Should we use grams? Should we use milligrams? Or should we use kilograms? Well, it doesn't really matter. The important thing is you need to be consistent with the unit of mass. So for example, if you want to use grams, your mass percent would be grams of solute divided by grams of solution times 100. If you want to use kilograms, then your mass percent is equal to kilograms of solute divided by kilograms of solution times 100. Again, it doesn't matter what unit of mass you are using. The important thing is you are consistent with that unit. And another important thing you need to take note, please remember that the mass of solution is equal to the mass of solute plus the mass of solvent. We will use this in the succeeding problems. Now let's proceed to answering actual questions. We have question number 1. A 15-gram aqueous solution contains 3 grams of NaCl. What is the mass percent of the solute? When you encounter this word aqueous, this means that the solvent is water. So the problem is asking us to solve for the mass percent of the solute, so we will use this formula above. Mass percent of solute, our solute is obviously NaCl. So mass percent of NaCl is equal to mass of solute. So mass of NaCl divided by mass of solution times 100. According to the problem, the mass of NaCl is 3 grams. And the mass of solution is 15 grams. So grams will cancel out. So we have 3 divided by 15 times 100. If you compute this using your calculator, you will get 20%. And this is the mass percent of NaCl. For question number 2, you can actually pause the video, try to answer this question on your own, and then if you have the answer, you can go back to check it. A sugar solution is prepared by dissolving 0.0750 kilograms of sucrose in 0.200 kilograms of water. What is the mass percent of sucrose in the solution? So in this problem, sucrose is our solute and water is our solvent. Always remember, the solute is the one being dissolved in the solvent. So sucrose is dissolved in water. So sucrose is the solute and water is the solvent. And the problem is asking for the mass percent of sucrose, so we will use this formula above. Mass percent of sucrose is equal to the mass of solute, so mass of sucrose, divided by the mass of solution times 100. In our problem, we are given the mass of sucrose, which is 0.0750 kilograms. However, we are not given the mass of solution. Instead, we are given the mass of solvent, 0.200 kilograms of water. But remember what I told you a while ago, that the mass of solution is equal to the mass of solute plus the mass of solvent. The mass of solute is 0.050 kilograms of sucrose plus mass of solvent is 0.200 kilograms of water. So 0.0750 plus 0.200, this is equal to 0.275 kilograms. So this is the mass of solution. So you plug this into your equation, divided by 0.275 kilograms times 100. So kilograms will cancel out. We have 0.0750 divided by 0.275 times 100, and this is equal to 27.3%. So this is the mass percent of sucrose, and this is the answer to the question. Question 3, again, you can pause the video and go back if you already have an answer. If you want to prepare 75 grams of 35% weight per weight aqueous solution of vitamin C, how much vitamin C do you need? So in this problem, vitamin C is our solute and water is our solvent because it's aqueous. So we will still use our formula. Mass percent of solute, our solute is vitamin C. Mass percent of vitamin C is equal to mass of solute. So mass of vitamin C divided by mass of solution times 100. We are given the mass percent of vitamin C, which is 35%. So 35.0 is equal to, the mass of solution is also given, 75.0 grams of aqueous solution. So 75.0 grams. We do not know yet the mass of vitamin C because it is the one being asked in the problem. So just put mass of vitamin C times 100. To solve for the mass of vitamin C, divide both sides of the equation by 100. So 100 will cancel on the right side. So we have mass of vitamin C divided by 75.0 grams on the right side. And on the left side, we have 35 divided by 100. That is 0.35 or 0.350. Next is to multiply both sides of the equation by 75.0 grams. So that 75.0 grams will cancel on the right side, and what remains on the right side is mass of vitamin C. And on the left side, we have 75 grams times 0.350. This is equal to 26.25, and the unit would be grams. So the mass of vitamin C that you need is 26.25 grams. And this is the answer to the question. Last question is question number 4. Again, you can pause the video and go back if you have an answer. A 5% weight per weight aqueous solution of acetic acid has a density of 1.05 grams per ml. What volume of water is in 200 ml of this solution? The density of water is 1.00 gram per ml. In this problem, our solute is acetic acid and our solvent is water because it's aqueous. We stick to the formula that we know. The mass percent of acetic acid, I will abbreviate this as AA. So mass percent of acetic acid is equal to mass of acetic acid divided by mass of solution times 100. If you read the problem, we are given the mass percent of acetic acid, which is 5.00. So 5.00 is equal to, we are not given the mass of acetic acid. So just write mass of acetic acid. Also, we are not given the mass of solution. Instead, we are given the volume of the solution, which is 200 ml. However, we are given the density of the solution, 1.05 grams per ml. So if you have the volume of the solution and you have the density, you can actually solve for the mass of the solution. So how do we do that? We are given 200 ml of solution. The density is 1.05 grams per ml. So 1.05 grams per ml. So ml will cancel. Now you have grams of solution. So 200 times 1.05, that is equal to 210 grams of solution. Now you can plug this to your equation for mass percent. 210 grams times 100. So let's solve for the mass of acetic acid. The same as what we did in question number 3, divide both sides by 100. So 100 will cancel on the right side. And on the left side, you have 5 divided by 100. That is 0.05 is equal to mass of acetic acid divided by 210 grams. If you multiply both sides of the equation by 210 grams, 210 grams will cancel on the right side, and what's left on the right side is the mass of acetic acid. On the left side, you have 210 grams times 0.05. This is equal to 10.5 grams. So the mass of acetic acid is 10.5 grams. The problem is not asking for the mass of acetic acid. It's asking for the volume of water. What volume of water? So how do we solve this? Remember what I said earlier, that the mass of solution is equal to the mass of solute plus the mass of solvent. Our mass of solution is 210 grams. So let me just highlight that. This is our mass of solution, 210 grams. Our mass of solute is 10.5 grams. So we can solve for the mass of solvent. So what you need to do is you just transfer 10.5 to the left side and it becomes negative. So 210 grams minus 10.5 grams. This is the mass of your solvent. So the mass of solvent, which is water, so the mass of water, 210 minus 10.5, that is equal to, wait a minute, that is not 199.5 grams of water. So now that we have the mass of water, and we are given the density of water in the problem, 1 gram per ml. Therefore, we can solve for the volume of water. So we have 199.5 grams of water. The density is, for every 1 ml, it weighs 1.00 grams. So grams will cancel. We have ml of water. So 199.5 times 1, that is just 199.5 ml of water. And this is the final answer to the question.